Welcome back to Econ. This talk is about growth calculations, and there's actually, strictly speaking, it's just about math and arithmetic. It really isn't about any economic concepts, but it could apply to things like compound interest, so how much will savings be worth in, let's say, 5 years at 6% interest? That type of question we could answer. Now, how much will you have in the bank if you start out with $1,000 and it accumulates at 6% interest for 5 years? And it also can be used for compound growth of GDP. So a question like, how big will China's GDP be in 2020 if it grows at 10% per year? So these are the sorts of questions we can answer using this growth arithmetic or growth calculations. And the basic formula we have is that, and I'll explain the notation in a minute. So this is the value you start with. So it could be your initial money in the bank, or the GDP in your starting year, something like that. R is the interest rate or growth rate expressed as a decimal. So if the growth rate, so if R is 12%, or so if the interest rate is 10%, then we would say R is 0.12. Or if your GDP growth rate is 3.5%, then we'd say R is equal to 0.035. So we move the decimal point over to express the interest rate as a decimal place. And then T is the number of years of growth. So if we keep money in a bank for 4 years, then T would be 4. If we're measuring China's growth over a 10-year period, then T would be 10. So this 0 is a subscript that says we're starting now, and then T is the number of years later. So that's our basic formula. So we'll apply it in a simple case. Let's just pretend we're counting the growth of gerbils, because it really doesn't have to be any economics. So Y0 is the amount of gerbils we start with. So we start, let's say, with 1,000 gerbils. Let's say we're T equals 4. We want to ask how many after 4 years. And let's say the growth rate is 14% per year. And so that's equal to 0.14. Alright, so we'll use our formula. We'll say after 4 years we're going to have 1,000 times 1 plus 0.14 to the 4th, which equals about 1,689. So that's how many gerbils we end up with at this growth rate for this number of years, for 4 years. Okay, so that's computing that. Now, what about one thing we could measure is the cumulative growth. So cumulative growth, I will simply define as yt divided by y0. So in this case, it would be 1689. Well, let me do it. Yt over y0 minus 1. Sorry, let me cross that out. Cumulative growth is equal to yt over y0 minus 1 times 100 to get a percent. So let's see what happens when we do it in this example. We get 1689 over 1000 minus 1 times 100, which is equal to 1.689 minus 1 times 100 is equal to 0.689 times 100 is equal to 68.9%. So we have 68.9% more gerbils than we started out with. So that's cumulative growth. The next thing I want to do is to calculate a compound rate of growth. So what is the rate of growth if you know yt and y0? So let's say we know our economy has a GDP in 2010 of 2.4 trillion, and let's say in 2000 the GDP was 2.0 trillion. What was the average growth rate? So now what we have in terms of our formula, we have t, which is 10. We went 10 years. We have yt and we have y0, and we're trying to find r. Okay, so so we can do a little algebra, and we can move the y0 over. We can say yt over y0 is equal to 1 plus r to the t, and then we can do some more algebra and get rid of the t by taking 1 over both sides to the 1 over tth power. So we get yt over y0 to the 1 over t is equal to 1 plus r. And then if we then subtract 1 from both sides, we get yt over y0 to the 1 over t minus 1 equals r, and r is what we're looking for. So now we just have to plug in and get those values. So in our example, where we go from a GDP of 2 trillion to 2.4 trillion over 10 years, we would have 2.4 over 2.0 to the 1/10 minus 1 equals r. And so that'll be our, which is 0.018 or 1.8%. So that's how we solve for a growth rate. And one final question we can ask is a question about what t would be. For example, we might ask if the US GDP is 2.4 and China's is, let's say, 1.6, and China is growing at 8% per year. Remember, that'll be 0.08 when we express it as a decimal. Then how long until they catch up to us where we are today? That is, how long before they reach 2.4 trillion. By the way, I have these numbers are totally made up. I have no idea what China's GDP is and US GDP is today. So don't take these numbers as serious numbers. Just I made them up and we're just doing arithmetic to solve the problem. Okay, so now we have we have yt equals y0, 1 plus r to the t, and we're solving for t because we have yt, that is, eventually we want China to be at the same as the US today. We know where China is starting out now, and we have China's growth rate of 0.08. So we have everything in the equation except for t. And how are we going to pull t out of there? Well, we'll have to use logs. So if we take the logs of everything, then we have log of yt equals t times log y0. Sorry, we don't multiply t times. We have log yt equals log y0 plus t log 1 plus r. And plugging in numbers, we would have log of 2.4 equals the log of 2.0 plus t times the log of 1.08. So when we finish taking all these logs, then we'll be able to solve for t. And the answer will be Oops, why did I put that 2.0 in there? I shouldn't have put 2.0. That should be 1.6. So let's get rid of the 2.0, put in 1.6, and now we can solve for t and we'll get the right answer. Hold on a second. Okay, so we get t is equal to 5.26. So if these made up numbers were right, it would take China 5.26 years to catch up to where we are today. So I suspect that those made up numbers are wrong. It'll actually take quite a bit longer, but it will happen at some point. And that's everything, all the arithmetic about growth calculations.